What we have here is question 3. A particle falls freely under gravity from rest at point P. After it has fallen for 1 second, another particle is projected vertically downwards with a speed of 14.7 meters per second. Find the time at which they collide. Okay, so actually I don't think this is a velocity time graph. Right, so what we have is two systems. We'll call it particle 1, particle A, particle B. Now we're going to UVAS both of them. Okay, now question is, at what time do they collide? What happens when they collide? What is the same? Distance. So S1 equals S2. So it does say that both distances are the same. Now, unlike most questions, this one has a time difference. How do you treat the time? 1 second. Another particle, we'll call that particle B. If one of them's in the air T amount, you can do that as T minus 1. Alternatively, and you'll get the same answer, you could have done T plus 1 and T, whichever one suits you. I'm probably just going to go for T minus 1. Okay? Now, both answers get you the same result, or both systems will get you the same result. There's no problem there. Now that that's done, what we're doing next is we need to find out acceleration. What's the acceleration? Now it's not minus 9.8. Why is it not minus 9.8? Not that. It's not going up and followed by down. If it's going up, it decelerates and then falls back down again. Because you're starting off with throwing it down and it just constantly goes down, you can say that it's plus 9.8. Yes? Okay. So, what happens next is we're just going to set up both systems. Did they start from rest? The first one starts from rest. The second one, not so much. So, the first one starts at 0. The second one starts at 14.7. We have S, we have U, we have A, we have T. Guess what form we're going to use? UT equals 1/2 AT squared. Now, so guys, what we're going to get is the first one, which is for A, we'll call it S subscript A, is going to be 0 times T is still 0. 1/2 of 9.8 is 4.9, and it's just T squared. The second one, which is SB, subscript B, the distance B covers, is going to be 14.7 times T minus 1. Then it's going to be plus 1/2 of A, which is 4.9, and then it's going to be T minus 1 squared. We're going to have to multiply this out. We're going to get 14.7T minus 14.7 plus, when you multiply that out, you guys do this in your sleep at this stage, so it should be T squared minus 2T plus 1. Multiply that by 4.9. 4.9 T squared minus 9.8T. That's when you multiply the 3 down by 4.9. And plus 4.9. Now, equals SA equals SB. So all this equals 4.9 T squared. Now guys, what do we know about the 4.9 T squared? So we're on both sides. You can sort of get rid of that. And then we're going to have 0 equals, we need to combine these together. So what's 14.7 minus 9.8? Anybody know? 14.7 minus 9.8? 4.9? Okay. 4.9T. And then minus 14.7 plus 4.9? I think that's going to be 9.8, is it? Minus 9.8. Now guys, move the 9.8 over the other side, divide by 4.9, and we get T equals 2. 2 seconds for that answer. Okay, how far below P do they collide? How would you find that out? How far is what type of question? Distance. Distance equals 4.9 t squared. So it's just going to be the distance equals 4.9 multiplied by 2 squared. What's 4 multiplied by 4.9? Can you tell me? What you get? Lads, use the calculator. 19 points? Thank you. Now, 98.6 meters. Show the motion of both particles on a speed-time graph. So we actually have to do the speed-time graph eventually, okay? So, here's what we do. In this case, we have a speed-time graph, so what we're going to do is we'll have now, the first particle we're going to say starts at t equals 0. And it starts off from rest, so it starts off here, and it just goes all the way up. Okay? The second particle, it starts a second later, so we're going to offset it by a second, and we're going to put it in 14 meters in the air. What can I say about both lines? And why are they parallel? Same acceleration. And eventually, at a certain time frame, basically you want the blue one, the shape of the blue one is a trapezium. So the area of the trapezium will eventually equal the area of the red triangle. And when that happens, then you know that both distances are the same, and that's where they collide. Okay, so that's your velocity time graph there. Very easy. Okay, moving on. Any questions? And just remember to offset it by a second, and you don't start off at 0 because you're starting off at 14. That's the only thing you need to remember.
Why is the trapezium equal to triangle?
At a certain point in time, they collide. When they collide, both distances are the same, and distance on a speed-time graph is the area underneath the graph. So one of these is a trapezium because it's a triangle on top of a rectangle. Yeah. Which means that when the area of A equals the area of B, so at a certain time frame, so at the moment you can clearly see that the triangle would be the bigger of the two until a certain point. Yeah. And then eventually they're going to be the same size, maybe around there. Like that triangle looks sort of similar to the trapezium, probably even a bit earlier in the day. That triangle is close to the size of that trapezium. When they're the same size, then they've covered the same distance. Yeah. Yes?
What the area of the distance is 14.7.
Oh, the air. Oh, it's acceleration. Oh. So in a velocity time graph, acceleration is the slope. Right. Okay, so in a distance time graph, you're right. The velocity is the slope. On the velocity time graph, the acceleration is the slope, and they're both following the gravity. Okay guys, moving on. Okay, and next one is number 5. A stone is projected vertically upwards with initial speed u rising 70 meters in the first t seconds and another 50 meters in the next t seconds. Find the value of u and the value of t. What type of question is this? Begins with an I. When you know it's an interval question, how do I know that's an interval question? Stone is projected vertically upwards. Okay? It goes directly up into the air. Stops at, sorry, it doesn't stop, but it rises 70 meters in the first t seconds. It then rises another 50 in the next t seconds. You technically have a system here, A to B to C. Now what do we tell, and it's thrown, has to be thrown against gravity, so it has the initial speed. What did I say about interval questions? What do you always do with your data sets?
Have a common starting point.
Have a common starting point. So I'm going to do data set AC and data set AB. AB and AC. Why do we do that again? What's the advantage? The U's are the same. The V's we never worry about. The A's is a minus or plus this time? Minus because it's slowing it down. Okay? So minus 9.8. Minus 9.8. S values? Anyone know the S values? 70 and 120. The T values. AB is T. This one here is 2T. Now, do we have enough to get this off the on the road here? Yeah, I think so. We're gonna try. Okay. So, oops. So guys, what we're going to try and do is, I reckon we just use UT plus a half AT squared twice, and then we'll have two equations, and with these two equations we can then figure out which variables to eliminate. I want to find the value of U and the value of T, so the only thing I need both of them. So guys, here's what we're going to do. We're going to start off with AB. 70 equals UT plus a half AT squared. UT being UT. Half AT squared being minus 4.9 T squared. On the second one, it's going to be 2T. So we're going to have 120 equals UT, but this time it's U times 2T. Minus a half AT squared is going to be minus 4.9 by 2T squared, 2T squared. So 120 equals 2UT. What's 4.9 multiplied by 4? Is it 19.6 again? 19.6 T squared. Now guys, look at this. We have two equations, okay? And look at the way the equations are written out. What can you say? What type of equations do you think these are? It's actually simultaneous. If we were to treat UT as X and T squared as Y, you'd have a very bog standard simultaneous equation, wouldn't you? That'd be 2x plus 19.6y, and that'd be x minus 4.9y. Okay, so you can actually see it's quite standard. So what I propose we do is we multiply the bottom one by minus 2. Multiply the bottom one by minus 2. So we're going to get minus 140 minus 2ut plus 9.8t squared. Add it on to 120 2ut, and then what else is there? Minus 19.6. And then we're going to find out that minus 20 equals minus 9.8 t squared. Divide 20 by 9.8. Anybody? This? It's not helpful. Alright. 20 divided by 9.8. Sorry? Okay, then square root it. So look, it's just going to be the square root of t squared equals okay. So basically t squared is going to equal your 20 divided by 9.8. That's going to get you what t squared is, 100 over 49. Okay, they're good numbers. It's going to be 10 over 7 when I square root that. Makes me believe I'm right. 10 over 7. Time taken is 10 over 7. Okay? Now we have to find the u value. How do we find the u value? We can just sub it into one of the values here. So we're going to put it in for, I'll do it on the green one here, okay? So the green one. So the green one, guys, it's going to be 100, it's set 10 over 7, sorry, excuse me. So it's going to be 70 equals u times 10 over 7 minus 4.9, 10 over 7 squared. Can somebody do this in the calculator? It's going to be 70 minus 4.9, 10 over 7 squared. Put that into the calculator. That equals 10 over 7u. Anybody on the calculator duty? Okay.
That would be plus.
What?
You run it over the equals.
It will be plus. So, we get here 70 plus 4.9 brackets 10 over 7 squared. We do that, we get 80. We have to divide this 80 by 10 over 7. When we divide it by 10 over 7, we find out that the initial speed is 56. So guys, u equals 56.